Okay, in the meantime, things that you can do while waiting is set up your plates. You always start with a spacer plate, which is a clear plate, and then you alternate actual plates. The way the assay is set up right now, and when we say by what we mean by assay is the parameters that the software is going to use to sample data. And so it's set up right now so that it can skip plates. It doesn't read each one. And the reason why we want to put a clear plate in between them is so that they can still have access to light. Otherwise, they would be in darkness, and we know that this will influence their rhythmicity. And so so the assay is set up to read every other plate, and it's set up to always skip the first plate. The assay is also set up so that it can sample only 8 plates per hour. So we have to exactly put 8 plates. If we put less, it would sample more per hour. If we put more, it's going to sample less per hour. Okay. Okay, so I'll continue telling you about this in a second. Since backup is done, right now we're going to set it up to delete. That also takes time, so we'll get it to run in the meantime. So now that we've finished backing up, we're going to delete. We stay in assay definition, and we go to, we go to file, and we go to delete, and we're going to specify the assay data that we're going to delete, and it's called do not delete. And we're going to say delete acquired data only. This tells it you're only going to delete the plates that we've read. You're not going to delete the assay, which is a set of parameters with which the software is going to sample with. That's very important, because if you don't press this, then it's going to delete the whole assay. It's not going to know how to sample data, and you're going to have to set it up from scratch. Okay? So assay, do not delete, and only delete acquired data only, and you press delete. And it's asking me, am I sure? Yes, I'm sure. It's telling me assay is currently in use, and that's correct, because here the software has the assay open. So you have two options. You can either close it, or you can change the assay that it thinks it's using. So I'm just going to put Cal 96, but now it's using something else. So that will prevent us. So now that will permit us to delete the data. It's the same thing when you try to delete a file on your computer that's in use, that's open. Okay. So file, delete, specify the assay, do not delete assay, delete acquired data only, delete, I'm sure, yes, I'm sure, now it's going to delete. Again, this is going to take time, so in the meantime, let's set up your plates. You have only 2 plates to set up. So we're going to have the clear plates, we're going to have fake plates, and we're going to have 6 of fake plates, because you only have 2 that you're setting up yourself. When I'm setting up a new experiment, I usually like to put my 2 plates in the beginning. So plate 1, so clear plate, plate 1, clear plate, plate 2. Now your experiment is done, so now we have to put fake plates instead. Clear plate, plate 3, clear 4, clear 5, clear 6, clear 7, clear 8. And then clear again. This last plate is very important. This last plate is very important, and it's different from all the other clear plates in that it has a barcode on it. The barcode plate always needs to go at the end right here. Okay? I'll explain to you why more, but now, since it's done deleting, let's do something in the meantime. Okay, so now, if you go to the TopCount software main screen, I think it's called TopCount Control, and you go to your assay that we usually use to sample data, you will see up here in the corner that we have 0 plates. That means we have emptied the database. Okay? So now we need to set it up so that it can start sampling new data. The first thing that we're going to do is we're going to go to Assay Wizard. Let me just check that this is what it's called. Okay, it's not giving me the name. I know it's called Assay Wizard. Click on it. Next. Work with an existing assay. Next. Specify the assay name with which you want to work with. It's called Do Not Delete. Next, don't do anything here at step 4. Next, don't do anything step 5. In step 6, click on report definition. Go to the second tab, and here we have some parameters to change. The first thing we're going to change is the file name that's going to be used to save each of the plate readings. Each plate reading will have a file of its own, but we want some sort of system in which those plate readings are stored. So what we do is we say that it's going to use the name TC2, because this is TopCount 2, it's the new one, and then it's going to use the date, which is today's date on which we've set up the assay. The date is 2014 06/27, and now we're going to tell it increment file extension after each plate. So each time it takes a reading of a plate, it's going to save that plate's information as this file name, and then 001, file name 002. Okay, and each plate will have that identity. Then we're going to specify where it's going to save this information from the plates. Right now, we've been saving things in my folder. I don't know if we created one for you yet. We don't have to. Let's keep them in mind for now. Okay? So, what I've done is on the desktop, I've created a shortcut for my files, which are really in my documents. So in my documents, there's data for Jade, but for me, it's easiest to create a shortcut on the desktop, and I access Jade from here. Within Jade, there are multiple experiments, and I call them I put each one of them in a folder, and I call the folder also by the date of the experiment. So today's date is 2014/06/27. So here's the folder in which we're going to save the data. I forgot to say that this is TC2. Okay. So TC2-2014-month-date. Then we're going to go into this folder, and we are going to tell the machine to save all the information from this experiment in this folder. And so if you see here, TC2-2014-06/27, this is the name that it's going to use to save the data. And then it says .1522 because this is the increment it has last reached, meaning the plate number that it had reached, because each plate has a different number. I'm going to delete this because now we're starting from scratch. And I say save. So now the assay says, okay, I'm going to save each plate information as this file name. I'm going to increment the extension of each file name. So plate 1 would be 001, 2 would be 002, and I'm going to save them in this folder. That's all you need to do here. It's very important that you don't touch anything else. You press OK. Next, you don't do anything on step 6. Next, you don't do anything on step 7. On step 8, we're going to have to do some things. But before we do anything on step 8, we need to calibrate the machine. So I'm going to leave this open on step 8 and not touch it, and I'm going to calibrate the machine. Calibration of the machine means the following. There are 6 detectors inside the machine, and each detector is designed to read a column. So what happens is that the detectors first will read every other well. So they will read column 1, 3, 5, and they will finish reading that. So they will read 6 out of 12, and then they will shift positions, and then they will read 2 and 4 and whatever. And so that way, it takes the detectors to position in order to read the full plate. Okay? You will see this after when it starts reading. But the point is that those detectors have different detection abilities. And it's very important that their detection abilities don't drift away from each other and stay within 5% difference. And so the calibration adjusts them so that their detection ability is as close to each other as possible. Okay? And what we use in order to do that is a specific calibration plate. Those are the plates here. They're radioactive, but the radioactivity is so small that they're not hazardous. It's very important though that they stay in this box sealed like this so that if the university personnel, they walk into the chamber and they see radioactive plates, they don't freak out because they don't realize that those are not hazardous. The calibration plate that we don't use, it says on it calibration normalization. So you take the plate, you place it here, just like that. You put the back stacker in. It's very important to put the back stacker in, otherwise the machine is going to give you an error. There are two ways with which you can do a calibration. One of them does not work anymore, we don't know why. And it says here, the hand with the plate, it means you manually provide the plate. Doesn't work, don't use it. Use the one with the stacker option, okay? And that's why it's important to put a stacker in the back. So now that this is here, I need to go to the calibration assay, and it's called Cal 96 on this machine, and I press start. Now it's going to take around 15 minutes in order to calibrate the detectors. You see, each one here is a different detector, and each number represents its reading ability. And so now it's going to take them and adjust them as close as possible to each other. Okay? So, while this is being done, I guess we can talk some more about these plates. So now we've put your plates here. It's very important that on your notebook, you write down the date, the machine in which you've set up your experiment, the time at which you've set up your experiment, and the position of the plates in which you've placed them in order here. Because later on, when you're going to take your file in order to extract the data, you need to know which plate you're actually on the list your experiment is actually located. If you notice here, by the way, we have the assay set up so that they delay 1 minute before reading any plate. I don't know exactly the science behind it, but all I know is that there is something called, I think, autobioluminescence, which is just as a result of light in the room and not necessarily as a result of the chemistry that's going on in the plates. And so what we do is we do a delay so that all this autobioluminescence dissipates first, and then we take a reading. And that will kind of take more accurate readings / eliminate some noise. That's the best way that I can describe it. Okay. So here it has started the calibration. Okay, so now that you've written the position, the date, the machine, and all that, we can put those in the stackers until we are ready to start.
Jay, just one question. So would this be position 1 and 2?
Position 1, position 2.
Okay.
Yes. When you look at your data file, the blank plates are not stored because we've told the assay to not take readings from the blank writes. So now we put this here. It's very important that they stay stacked nicely to each other. So as I do this, I kind of press down at the same time and move them kind of to make sure they're still stacked in properly. There are springs at the bottom of the stacker on which they're going to land. Sometimes the springs are maladjusted, and it's important that you examine that the plates here are completely perpendicular to the line here, or are completely parallel to the line here, and that should tell you that they are perfectly adjusted. Otherwise, when the machine is going to come and try to take a plate, it's going to take them unevenly, and the plate's going to get stuck. Once you place them in here, you're going to put, I forget what it's called, the weights, whatever. I think it helps to push things always down equally. I don't know, something along those lines. Okay, so now that this is ready, we have to wait until the calibration is done. So I think you can pause now.